Hi everyone, we would be starting your 12th module for Chemistry for Engineers. This is all about some calculations related to nuclear chemistry. And this is our objective, applying knowledge in mathematics and science to solve engineering problems. So as per the title of the presentation, this is actually purely solutions or calculations related to the nuclear reaction. So you'll see here scenarios in which we would actually use the formula for energy that is actually discussed in your module 10. So we would be starting in this problem. So calculate the energy released by a nucleus of uranium-235 if it splits into a barium 141 nucleus and a krypton 92 nucleus. So we have here, we're fortunate enough that we're given the equation. Okay, so now we will be executing based on our formula. So let me just show you the calculator because we'll be using it. Okay. So we have here our calculator. So it's a bit big. Okay, so let's try to solve this problem. So first off, we have the formula E is equal to mc squared. And we all know that when we're analyzing nuclear reactions, this m would be delta m, okay? Or the change in mass with regards to the product and the reactants, okay? Multiplied by the c, which is the speed of light, okay? So which is a constant element naman. Okay, so first off, we would have to get the delta m, okay? So getting the delta m, we would have to get the mass of the reactants, which is this, and the mass of the product, okay? So I would be getting first the mass of the reactants, okay? So that would be uranium-235. We have here the mass 235 0.439 plus neutron. So 1.008669 U as well. Okay? So let's try to solve it using our calculator. That would be 235.0439231 plus 1.008664. So that would be equal to 236.05258. Okay? So U is the unit. Okay, next, we'd get the mass of the products. Okay, the products are this. So again, this is your MR. This is your product. Okay, get the mass of the product. So we have BA, that's 1 for 1. It's 1 for 1. 0.9144064 plus KR. KR is 91.926152 plus 3 daw na neutron. 4, 9. Okay, that would be equal. Let's use our calculator again. So that would be equal to 141.914400 plus 91.9261528 plus 3 times 1.0086649. Okay, that is 235.8665539. So, lagay natin 35. Rechecking, baka tayo nagkamali ng input. So, 141, 944, 91, 926, sorry, 91, 926, and 100649. Hi, so that would be equal to 23, tama naman siya, 236. 236.8665539. Okay, so getting the mass defect, okay, so we would have to subtract our mass of products to our mass of reactants. So mass defect, our delta M is equal to 236.8665539 less 236.052588. They are both in U. Calculator natin, that would be less 236.052588. So that would be 0.08, 0.8139659. As you can see, I'm avoiding the scenario wherein I would be rounding off in the middle of solution. Normally, when we're solving, we are actually trying to do with the rounding off at the end of our solution so that we can be sure that all the decimal places are considered in our solution. So next, we can now solve using our formula since we have found out the mass defect. Okay, so using the formula E is equal to mc squared, I'll be going here. E is equal to delta M C squared. Okay, so our delta M is 0.81399659 multiplied by, okay, so this is in U. Okay, converting U first because our unit for energy is joules. So 1 U is 1.66053886 times 10 raised to negative 27 kilograms. Okay, so again, that's converting lang into kilograms. And then, multiply natin siya sa, dahil joules is meter per second squared, ay, kilogram meter per second squared. Okay, so, multiply natin siya sa speed of light na constant, which is the C. 2.9979 2458 2458 245 pala. 2458 6 times 10 raised to 8. 2.9979 2458 times 10 raised to 8 meter per second speed of light. Okay, let's square that. Okay, so using this, calculate natin siya. That would be equal to 0.813969U times 1.6605 3886 times 10 is to negative 27 and times 2.9979 245 times 10 raised to positive 8. Quantity squared. Okay. That's 1.2148. I'll settle with 4 decimal places. Times 10 raised to negative 10 joules. Okay. So, since wala naman siyang specify na unit, I would be using the major unit for energy, which is joules. Okay. So, that would be 1.21447, okay, 48, okay, times 10 raised to negative 10 joules. Okay. So, next. Okay. So, we have here our second example. So, let me just shift to no calculus so that you can see the problem as a whole. So, what is the energy in joules and in mega electron volts or MeV associated with the decay of uranium-238 to thorium and helium? Okay, so since we're given the equation again, so we would be doing the same process as what we did before. So, trying to first analyze the mass defect. So, first off, again, this would include this formula. Okay. So mass defect for the, first off, you would have to get the mass defect for the reactant and the mass defect for the product. Okay. So first off, we have our uranium-238. Okay. So unfortunately, it wasn't given. Okay, but we can actually get the uranium-238 from the table. Okay, supposing, since I have the table naman alongside with me, I have the book for the table. Supposing I have uranium, the mass in U, atomic unit is 238.0508 U, and then thorium is 23. This is mass in uranium, right? Thorium. So that's 234.0437. And then for helium, we have 4.0026. Okay, U. Okay, so again, that's 23805 08U and 2340437 U, and then helium is 4.0026. Okay, so we can now get for the mass of the reactant and the mass of the product. Okay, so first off, we have the reactant as U lang or uranium lang. Okay, so we would be getting it here. Mass of the reactant is equal to 238.0508 U, and the mass of the product is equal to thorium 2340437 U plus 4.0026 U. Okay, so let's try to use our calculator. I'll shift with the calculator view. Okay, that would be 234.0437 plus 4.0026. Okay, that would be equal to 238.0463 U. Okay, so next, since we got both the mass of the reactants and the mass of the product, we can compute for the mass defect or the delta M. Okay, so that's 238.0463 minus 238.0508 U. Okay, so using the calculator, less 238.0508. That would be negative 4.5 times 10 raised to negative 3. So using that delta M, we can now get the value of the energy. So that's negative 4.5 times 10 raised to negative 3 U. I'm converting the U again. So 1 U is again equal to 1.6053886 times 10 raised to negative 27 kilograms. Okay. Though you would see, pwede naman yung gamitin yung direct conversion of U to joules. Yun nga lang minsan kasi, halimbawa may given kayong kilogram. So yun, may mga scenario. Kaya, ino-opt natin gamitin yung traditional conversion. So, speed of light, 2.9979248 times 10 raised to 8 meter per second. Okay, so that would be squared. Okay, so let's solve for this. Times 1.66058 86 times 10 raised to negative. In the future, you may opt to have this under your, store nyo siya sa values inside your calculator. Pwede naman, since di pa naman board exam to, pakistore para hindi na kayo masyadong ma-prone sa error. 2.99792458 times 10 raised to 8. Okay, so squared. That's negative 6. Okay, so negative 6.71. Negative 6.715. 4 na lang ulit. 9. Okay, times 10 raised to negative 13 kilogram per meter squared. Okay? Or negative 6.7159 times 10 raised to negative 13 joules. Okay? So, since ang hinahanap niya ay in joules and in mega electron volts, so convert din natin itong joules na, value natin into mega electron volts. Okay? So, convert natin. So, oops, is equal to, I would use yung basic na U kasi mas madaling tandaan yung value. Okay? So, 1 U is actually equal to 931.5 MeV or mega electric volts. Okay? So, calculator. Okay? That's negative 4.5 times 10 raised to negative 3 times 931.5. That's negative 4 decimals na lang ulit. 4.1918. Okay? Na M-E. Okay? So that's the answer for problem number 2. Next, we have example number 3. Okay, supposing we have 50 gram was lost in a mass as a result of fissionable reaction. How much energy is released? A 3.2 kilogram loss, a 112 gram loss. So distinctively, we have 3 scenarios here. The first one is what if 50 grams daw yung nag-loss na mass? Second is what if 3.2, and third is what if 112 grams ang loss. Okay, so technically this is very simple. So that's if in case you would remember always the formula of energy, which is mc squared. Okay, so let's do the first one. This is using the 50 gram. Okay, so since kilojoules per meter squared second squared tayo sa joules, so let's convert this to kilograms. Okay, so kilograms. So 1 kilogram is equal to 1,000 grams. Okay, so if I'm not mistaken, so 50 divided by 1,000. Sorry, I used my calculator na lang para mabilis. Okay, so that would be equal sa 0.05 kilogram. Okay, so first off, using the formula, we have, ang tinatanong niya ay, how much energy is released? Okay, so we have M as 0.05. Kumbaga parang given na yung delta M. Okay, so since sinabi na niya kung ilan yung nawala na mass. So 0.05 kilogram. Okay, and we would use the formula, the constant of energy of speed of light 2.9979245 times 10 raised to 8. Okay, so medyo mahaba siya. Simplify natin. Some books naman kasi are using this. So if in case hindi naman strict na yung as in buong decimal places ang gagamitin nyo, pwede namang ito ang gamitin nyo. Okay, so ito ay 3.00 times 10 raised to 8 meter per second squared. Okay. Normally, sige, para i-standardize natin, if in case lang I am not specifying to use yung massive decimal places, you can opt to use the 3.00 times 10 raised to 8. Kasi this is very much prone to error, okay? But if I specifically stated in the problem that you have to use yung specific na value of the speed of the light, so ito yung ibig sabihin nun. But if in case you could just specify, you can opt to use this 3.00 times 10 raised to 8 meter per second squared. Okay, so calculate natin siya. Where's my calculator? Okay. That would be equal to 0.05 times 3 times 10 raised to 8. Okay, so that's 1.5. Okay, so if I'm not mistaken. Oops, I think I have done something wrong kasi, ano ba? Raised to 8. Raised to 8 din naman si, okay. Kulang tayo sa squared. Okay. Okay, so that's 4.5 times 10 raised to 15. Please do not forget to always check yung mga ini-input nyo sa calculator because commonly, whenever I'm solving for the energy, I most of the time forget the squared or indicate the squared in the calculator. So yun, please don't forget that. It's also included in your formula. Okay, for letter B. Letter B asks for 3.2 kilograms. So same process. So since it's already in kilograms, so direct substitution na lang siya. 3.2 kilogram. That's 3.00 times 10 raised to 8 meter per second squared. So using the calculator again, so change ko lang to. Or hindi na ako magde-delete. So that's 3. That's 2.88 times 10 raised to 17 joules. So, rechecking kung joules lang talaga, wala naman siyang hinihinging specific unit of energy. So, I would settle for the general unit of energy, which is joules. Okay, next, lastly, we have 112 gram law. So, it's somewhat the same with the first one. Convert the 112 muna to kilogram. 1 kilogram. Okay. So, use the calculator na lang para mabilis. Okay, that's 0.112 kilograms. Okay, so using the formula of energy, we have 0.112 kilograms times 3.00 times 10 raised to 8 meter per second squared. Okay, so using the calculator again, so we have to change lang natin itong dalawang to. 0.112. Okay, so that's equal to 1.008 times 10 raised to 16. Okay, so that's for example problem number 3. Next, we can have example problem number 4. Example problem number 4, we have 350 atoms of uranium-235 split. Okay? And if 2.9 times 10 raised to negative 8 joules of energy is released from each atom when fusion occurs, what nuclear mass is converted into energy? Okay, so technically, so it's actually looking for the mass. Okay, so given si energy, given si constant, syempre, ito naman daw yung hinahanap natin, si mass. Okay, so using the formula, pwede naman natin iikot yan. So ilipat na natin to para nagsosolo si M sa kabila. Okay, so M is equal to E over C squared. Okay, so getting the given, so we have E over C squared, okay? The value of E is actually 2.9 times 10 raised to negative 8 joules, okay? Pero sabi niya, 350 atoms daw yan, okay? So, times 350 na atoms ng uranium ang ginamit nila over the constant 3.00 times 10 raised to 8 meter per second squared. I know that's a lot easier to remember, yung 3.00 na yan. Okay, so let me just transition to the calculator scene and let me just grab it. Okay, so that would be, edit ko na lang to para hindi na ako magta-type uli ng, okay. So that would be 2.9 times 10 raised to negative 8. Ay, ano ba yan? Times 10 raised to negative 8. Okay, this is not multiply, this is divide. Okay? Wait. I have to multiply din sa 3 there 3. So that would be equal to 1.1278, okay, times 10 raised to negative 22 na kilograms. Okay, so, okay. So, again, this is our answer for this problem. That ends our calculations for nuclear reactions. I hope you've learned. So for questions and clarifications, please feel free to message me on links again. Thank you so much.